When we look up at the night sky, we naturally wonder where it all ends. But to understand the scale of what is above us, we have to start with the scale of our home, a world of deep oceans, 5 million species, and vast mountain ranges that take a lifetime to explore. This animation illustrates the physical size of our planet. If you were to walk the entire circumference of the Earth at a standard pace of 3.1 miles per hour, it would take you 11 years of non-stop walking to complete the journey. While the ground feels static, it is actually spinning on its axis at 1,038 miles per hour. Simultaneously, we are orbiting the Sun at 10,563 miles per hour. Our sensory experience is designed to mask this constant, high-speed cosmic momentum. Moving vertically away from the surface, we pass through 5 atmospheric layers. In the mesosphere, the temperature drops to -130 degrees Fahrenheit, acting as a barrier where incoming meteors burn up before they can reach the ground. Higher up, the thermosphere reaches 2,732 degrees Fahrenheit. This is the environment where we maintain our satellites and the International Space Station. Beyond the final layer, the exosphere, the protection ends. Without these layers, the radiation of space would leave the Earth lifeless. The first major landmark in the deep black is the Moon, our closest celestial neighbor. Though it looks close, the Moon is 238,855 miles away. This model shows that you could fit 30 Earths in the empty void between our world and theirs. To put that distance in human terms, driving a car at 62 miles per hour would take 170 days of continuous travel to reach the lunar surface. Past the Moon lies Mars. From the Martian surface, the Earth is no longer a world, it is just a point of light. Even our nearest planetary neighbors are separated by these massive, hostile gulfs of empty space. Zooming out further brings the entire solar system into view, anchored by the Sun, a star weighing 200,000 trillion tons. Light travels at 186,000 miles every second. Even at that speed, it takes 8.3 minutes for a photon to cross the 93 million miles from the Sun to the Earth. Then there is Voyager 1, the human-made object that has traveled the farthest distance from Earth. This diagram shows Voyager's path. It has been flying at 38,214 miles per hour for 46 years, yet it will need another 30 years just to exit the 18.6 trillion miles solar system. Humanity's fastest technology has barely pushed us out of our own cosmic driveway. Beyond the solar system, we encounter stars that make our Sun appear microscopic, such as the supergiant UY Scuti. Here is our Sun, with a diameter of 432,685 miles, plotted next to UY Scuti's 745 million mile span. You could fit 5 billion of our suns inside it, and it burns 340,000 times brighter. The night sky we see from Earth is a narrow perspective. It contains only a tiny fraction of the galaxy's 100 billion stars. This chart highlights our limit of reach. That yellow dot is our total radio broadcasting range. If alien life exists outside that circle, we cannot find them. Our neighbor, the Andromeda Galaxy, contains 1 trillion stars and takes 250,000 light-years to cross from one end to the other. Both our vision and our voices are effectively trapped in a small pocket within just one galaxy. Leaving the local group of 54 galaxies, the scale shifts from millions of miles to millions of light-years. We enter the Virgo supercluster, a web spanning 110 million light-years. Further out lies the Laniakea supercluster, stretching 520 million light-years wide. This entire structure is what we call the observable universe. Traveling to the edge of this observable boundary would take 46.5 billion light-years. Research suggests this is only a fraction of what exists. If the observable universe were the size of a football, the total physical universe would be the size of the Earth. This reaches a point where the physical universe exceeds the reach of any possible observation. This vastness is why Voyager 1's final photograph is so significant. There is Earth, a single pale blue pixel. Every joy and sorrow, Every hero and villain, every religion, and every ego that ever claimed "this is mine" existed on that one dot. We are one species among millions on a tiny speck, attempting to uncover the secrets of a void that is effectively infinite. When viewed against this physical scale, human self-importance has no measurable weight. While light is restricted by physics, we can shift our perspective instantly. We can map the surface of our planet and the edge of the universe in a single sequence of thought. In this structure, the physical space we occupy is less than a single particle of dust.
Looking at the night sky provides a context that makes our earthly conflicts over status and borders seem like a great irony. We occupy a physical space that is effectively zero, but from that single point, we have managed to measure the light that defines the edge of everything.